of the solid obtained by rotating the region bounded by the given curves about the specified line. So we have the graph of this region here, and if we were to rotate it about the line x equals 1, it would go around this line here. And if we did that, we would wind up with a mirror image of this shape. And if we think about this distance here from the line x equals 1, which is our axis of rotation, and this vertical line that represents the boundary of this shape, it's 2 units away from our axis of rotation. So if I count 2 units over and then draw a line, vertical line, that is 3 units tall, then there's the matching edge of that region, and then go over another 4 units, I would get the other edge, which would go up to the point -5.7. And then it has this top. And so our matching region, after we rotated about that line, would be here. Now, because the left and right edges of this thing aren't consistent from top to bottom, I'm going to draw a vertical representative rectangle, which is parallel to the axis of rotation, which means that I will be using the shell method for finding this volume. And if we rotate about this line, we would have something that looks like this. And it would occur at this arbitrary x sub I. So now I'm going to think about looking at this from the top. And if I do, then I would have a circle that would be right about here. And it would have a thickness and if I centered the whole thing better, actually, this line here that we're rotating about should go right down the center. And what we're interested in here would be the radius of this shell. So the radius of that shell would go from our axis of rotation out to our arbitrary x value. Now that axis of rotation is the line x equals 1. So the length now, this radius here, r sub I, would be our x value here, x sub I, minus the 1 that is the x coordinate of that, all the dots on that axis of rotation. And now, if we think about the process of breaking that shell open and laying it out flat, we would wind up with a big rectangle here. And it would have some thickness to it. Giving us a 3D figure here. that would have a volume. Now what we need to do is match up the parts of our shell here with this rectangular volume when we crack it open. Now something we need to think about is, since we made our representative rectangle to be vertical, it dictates that the thickness of that thing is delta x, which would be this dimension, the thickness of our rectangular figure. That also dictates then that our variable of integration will be x. The horizontal dimension of our rectangular figure will just be the circumference of that shell. And if we think about that, that's just 2 pi r, which would be 2 pi times x sub I minus 1. The height would be the y-coordinate of this dot, x sub I, y sub I. And on that line, y and x are the same because that is the line y equals x. So if the coordinates of that dot, x sub I, y sub I, are the same, then we can just use x sub I as the vertical height here. So now, a volume then would be v sub I equal to length times width times height. So 2 pi times x sub I minus 1 times x sub I times delta x. And we could distribute that x sub I, and we'd have 2 pi x sub I squared minus x sub I delta x. And an estimate of the entire volume that we would have once we've completed this process would be the sum, I equals 1 to n, 2 pi x sub I squared minus x sub I delta x. But that would be a finite number of those shells. The actual volume we could find by letting the limit of the number of those shells go to infinity. Sum I equals 1 to n, 2 pi x sub I squared minus x sub I delta x. But that would be an integral, so the volume could be expressed exactly as the integral. Now, x is our variable of integration, and if we think about where we start and stop these x values when we draw those representative rectangles, it would start at 3 and end at 7. 2 pi x squared minus x dx. And if we evaluate this integral, then we would wind up with that actual volume. So we'd have 2 pi 1/3 x cubed minus 1/2 x squared evaluated from 3 to 7. And that volume would wind up being 512 pi over 3.